In this work, we propose a method for generating an animation from still manga contents using camera movements. Given still manga contents, we generate an animation that effectively tells the story, by simulating camera movements over the manga contents. Given a manga page, our approach begins by automatically extracting panels, comic characters and their balloons. We next estimate the motion and emotion states for each panel. We build a chain-structured graphical model on the page, where each node represents semantic states to be estimated. The inputs are a set of low-level features, which are based on motion lines, background textures and intensity, and balloon and panel shape. The model accounts for interactions between neighboring panels by connecting consecutive nodes. Given the inputs, the semantics are inferred using the probabilistic model. In the final step, we simulate camera movements over the page, using the extracted elements and estimated semantics. We consider three basic types of camera movements: pan, zoom in and zoom out. In film production, panning shifts the audience's focus from one subject or location to another. Zooming in can focus the audience on a character, showing the character's reaction or emotions. While zooming out can pull the audience away from the character, putting the character in context. We combine this knowledge of film production and the characteristics of manga to generate camera movements over the page, which can effectively tell the story. We also include several special effects, such as shaky effect, motion blur and moving motion lines. The shaky effect is used to increase the level of anxiety and tension. The motion blur and moving motion lines can enhance the sense of motion. To evaluate the effectiveness of our approach, we compare it with two alternative methods for generating animations from still photos via camera movements. We first compare our approach to Microsoft Photo Story, which animates photos using random camera movements, similar to the Ken Burns effect. The random nature of this method breaks the structure of manga contents, which is designed by artists to develop the story. Hence, it fails to generate a plausible animation for storytelling. In contrast, our approach produces meaningful and consistent camera movements, by using knowledge of film production and characteristics of manga. We next compare our approach to moves on stills, which guides camera movements using eye movement data. Moves on stills cannot fully express the pace of the story, due to the lack of semantic understanding of the contents. In contrast, our approach can faithfully reproduce the story pace by varying camera movement speeds and patterns based on the inferred semantics. We demonstrate two applications of our approach. First, our animation can be used to improve comic reading on mobile devices. When reading comic pages on a small screen device, readers are forced to frequently pan and zoom to view contents at different locations and scales. This is cumbersome and tedious. Using our animation, we created a dynamic comic reader, where readers advance through the story by simply tapping the screen. Second, our animations can be easily turned into comic trailers, by post-processing with video editing software. We show a comic trailer produced from our animation by adjusting the playing speed and adding a soundtrack. This is the end of our video. Thanks for your watching.